So hello everyone, today I will explain about the storage. So in storage system in DBMS, a database system provides an ultimate view of the stored data. There are types of data storage. First one is primary storage, second one is secondary storage and tertiary storage. So in primary storage, the memory storage that is directly accessible to CPU comes under this category. In secondary storage includes memory devices that are not part of the CPU chipset or motherboard. In tertiary storage, uh, it's used to store huge volumes of data. So redundant array of independent disks, short form of this is RAID, is a technology to connect multiple secondary storage devices and use them as a single storage media. So what is storage system in DBMS? Here is the flowchart. First step is user, then DBMS, then access method and then data storage. As we already know that user operations are expressed via DML in terms of external records and must be converted by the DBMS into corresponding operations for internal or stored records. The stored record interface thus corresponds to the internal level just as the user interface corresponds to the external level. The physical record interface corresponds to the actual hardware level. So specifically, DBMS known as the following: what stored files exist and for each one, the structure of the corresponding stored record, the stored record files, if any on which it is sequenced. The DBMS doesn't know the following: anything about the physical records or blocks, how stored fields are associated to form stored records. So the file structure. The file is the collection of records. Using the primary key, we can access the records. This method defines how file records are mapped onto disk blocks. So this is the file structure. First one is the file header. In this method, we store the record in the sequence that is one after another. Second method is sorted file. In this method, the new record is always inserted at the file's end, and then it will sort the sequence in ascending or descending order. So what are the pros and cons of sequential file organization? So pros are fast and efficient method for huge amount of data. Second one is simple design, and third is files can be easily stored in magnetic tapes. That is the cheaper storage mechanism. What are the cons? Time wastage, as we cannot jump one particular record that is required, but we have to move in sequential manner, which takes our time. Sorted file method is inefficient as it takes time and space for sorting records. File structures. Heap file organization. It works with the data blocks. When the records are inserted, it doesn't require the sorting and ordering of records. When the data block is full, the new record is stored in some other block. What are the pros and cons of heap file organization? Pros. Fetching and retrieving records is faster than sequential record, but only in case of the small databases. When there is a huge number of data needs to be loaded into databases at a time, then this method of organization is best suited. Cons. Problem of unused memory blocks and inefficient for larger database. These are the cons. Next type is hash file organization. In a database management system, when we want to retrieve particular data, it becomes very inefficient to search all the index values and reinsert that data. In this situation, hashing techniques comes into picture. So there are hash file organization, data bucket. Data buckets are the memory locations where the records are stored. These buckets are also considered as unit of storage. Then hash function. Hash function is the mapping. So hash function is a mapping function that maps all set of search keys to actual record address. And third one is hash index. The prefix of entire hash length value is taken as hash index. Every hash index has depth value to assign how many bits are used for computing the hash function. Then the another type of file structure is static hashing. In static hashing, when a search key value is provided, the hash function always computes the same address. So here is the example is given. There are dynamic hashing. The drawback of static hashing is that it does not expand or shrink dynamically as the size of database grows or shrinks. In dynamic hashing, data packets grows or shrinks as the record increases or decreases. This is the advantage over static. So hash file uses the computation of hash functions on some fields of the records. The hash function's output determines the location of this block where the record are to be placed. Next one is the B plus file organization. So B plus tree file organization is the advanced method of an indexed sequential access method. It uses a tree-like structure. Index sequential access method, that is the ISAM. ISAM method is the advanced sequential file organization. In this method, records are stored in file using the primary key. Next one is the cluster file organization. When the two or more records are stored in the same file, it is known as the clusters. These files will have two or more tables in the same data block, and the key attributes which are used to map these tables together are stored only once. In the Here is the example is given. Types of cluster file organization. First one is the indexed cluster. In index cluster, record are grouped based on the cluster key and stored together. The employee and department relationship is an example of index cluster as given on the right side. The second one is the hash clusters. It is similar to the indexed cluster. In a hash cluster, instead of storing the records based on the cluster key, it generates the value of hash key for the cluster key and store records with the same hash key value. Now we will see the indexing. What is indexing? Indexing is defined as a data structure technique that allows you to quickly retrieve records from a database file. Indexing is used to optimize the performance of database by minimizing the number of disk accesses required when a query is processed. So what are indexing attributes? Standard bit tree and bitmap. A B-tree is a type of tree data structure that contains two things, namely index key and its corresponding disk address. Index key refers to a certain disk address, and the disk further contains rows or tuples of data. Next one is the ascending and descending. Columns of the index are stored in some sorted manner. Generally, we store the search key in ascending order. This sorted keys allows us to search data and data fastly. By default, sorting order is character data sorted by the ASCII values of characters. Numeric data is sorted by smallest to biggest numbers. And third one is date, earliest date to the latest date. So types of indexes are single level indexing. It is somewhat like the index or the table of the contents found in the book. And then the primary indexing. The indexing or the index table created using primary keys is known as the primary indexing. It is defined on ordered data. What are the characteristics of primary data? Search keys are unique. Search keys are in sorted order. Search keys cannot be null as it points to the block of data. And third is the fast and efficient searching. Types of indexes, that is the dense index and sparse index. Dense index, a record is created for every search key value in the database. So that is the dense index. And sparse index is, in this method of indexing technique, a range of index columns stores the same data block address, and when data needs to be retrieved, the block address will be fetched. These are the types of indexes. Secondary indexing. It is two-level indexing technique used to reduce the mapping size of the primary key. So these are the characteristics of indexing. Search keys are candidate keys. Search keys are sorted, but actual data may or may not be sorted. Requires more time than primary indexing. Faster than clustered indexing, but slower than primary indexing. So next one is cluster indexing. Clustered indexing is used when there are multiple related records found at one place. To achieve faster retrieval, we group columns having similar characteristics. The indexes are created using these groups, and this process is known as clustering index. Then next one is the multi-level indexing. Since the index table is stored in the main memory, single level indexing for huge amount of data requires a lot of memory space. Hence, multi-level indexing was introduced, in which we divide the main data block into smaller blocks. So This is the B-tree index. The leaf nodes are themselves in the form of a linked list. This linked list representation helps in the both sequential and random access. In hashing technique, hashing technique is used to calculate the direct location of data record on a disk without using the index structure. So that's it. That is the storage processing DB.